20 billion galaxies, millions of asteroids, an entire continuous 10-year record of every visible change happening across the night sky. That's what just went live. And within the very first hours of real operation, a brand new telescope in the mountains of Chile found more previously undetected objects flying through our own solar system than most observatories catalog in an entire year. Some of them were already surprisingly close. All of them had been there, undetected, the entire time we've been looking up at what we thought was a mostly empty sky. This is the story of what the Vera Rubin Observatory has actually found now that its real, full-scale survey has finally begun, why the scale of what it's revealing is genuinely unsettling once you sit with the numbers, and what that discomfort is actually telling us about how much of our own cosmic neighborhood we've never properly mapped. Well, let's start with what actually just happened, because the timeline matters. On June 30th, 2026, SLAK National Accelerator Laboratory formally announced that the Vera Rubin Observatory had begun its real, full 10-year mission, officially named the Legacy Survey of Space and Time. This wasn't the observatory's debut. That had come a year earlier, on June 23, 2025, when the facility released its first test images to the public at an event in Washington, D.C. Images that already contained an estimated 10 million galaxies in a single combined photograph. But that earlier release was commissioning data, a proof of concept demonstrating the telescope's capabilities before the real, continuous, decade-long survey formally began. The technical checkouts required to confirm every system, every camera component, and every piece of the massive data pipeline was actually functioning correctly, took longer than the team originally projected. Getting it right mattered more than hitting an early deadline, because once the real survey started, it was meant to run, uninterrupted, every few nights for 10 consecutive years, a genuinely irreversible, decade-long commitment that couldn't simply be restarted if something had gone wrong partway through. The observatory itself sits at 2,782 meters atop Cerro Pachón in Chile, chosen specifically for its dry air and exceptionally dark skies. Built around an 4-meter telescope feeding the largest digital camera ever constructed, jointly funded by the U.S. National Science Foundation and the Department of Energy after more than 2 decades of planning and engineering. It's named after Vera Rubin, the astronomer whose measurements of galaxy rotation in the 1970s provided some of the first strong evidence for dark matter. Work she pursued for years in a field that offered her little institutional support at the time. Now that the survey has actually started, the discomfort in this story starts to become clear, and it has nothing to do with anything threatening us directly. It has to do with the sheer, almost vertigo-inducing scale of what Rubin is capable of finding, and what that scale reveals about how much we simply hadn't been looking at closely enough before. Consider what happened during Rubin's earlier commissioning period, before the real survey had even begun. In just over 10 hours of test observations, spread across roughly 9 nights between late April and early May of 2025, Rubin identified 2,104 asteroids that had never been cataloged before, anywhere, by any observatory on Earth or in space at any point in human history. 7 of those were near-Earth asteroids, meaning their orbits bring them into the general vicinity of our planet's own orbital neighborhood. NASA was careful and specific in describing those 7. They pose no danger. For comparison, every combined observatory currently operating on the planet typically discovers around 20,000 new asteroids in an entire year. Rubin found over 2,000 in 10 hours during a test run before its actual mission had formally begun. Once the full 10-year survey was properly underway, officials at the observatory projected that Rubin would discover millions of new asteroids within just its first 2 years of full operation, effectively multiplying humanity's entire historical catalog of known solar system objects within an almost absurdly short window of time. Sit with that specific number for a moment, because it's the part of this story that should genuinely unsettle you, in the most honest, productive sense of that word. Millions of objects currently orbiting the sun in the same general region of space we occupy that no human being, no telescope, and no tracking system anywhere on Earth currently knows exist, not because they're new, not because something has changed about how many asteroids populate our solar system, because we simply never had an instrument capable of finding them before. They've been there the entire time, drifting through the same neighborhood as Earth, invisible to every previous generation of survey telescope, waiting for something with Rubin's specific combination of an enormous field of view, extraordinary sensitivity to faint light, and the ability to revisit the same patches of sky repeatedly, finally arrived to notice them. That capability became formally, continuously active earlier this year. In February of 2026, Rubin Observatory launched its real-time alert system, a genuinely historic piece of infrastructure specifically designed to flag and broadcast newly detected changes in the sky, supernovae, moving asteroids, and other transient events, essentially as they happen, to the wider astronomical community. That system means Rubin isn't simply gathering data to be analyzed months or years later. It's actively, continuously scanning the sky and immediately raising a flag the moment something new, or something moving, or something previously undetected shows up in its field of view. Every single night for the next decade, that alert system is expected to fire repeatedly, each alert representing something real, physical, and previously unknown, newly confirmed to exist in the same solar system we live in. Among the very first objects cataloged during this commissioning period was 2025 MN45, a main belt asteroid roughly 710 meters across, wider than most skyscrapers are tall, first observed by Rubin's own telescope on May 2, 2025, and later traced back through the observatory's own archived images to as early as September of 2019, years before Rubin itself even existed in its current operational form, an early demonstration of exactly how much retroactive value this kind of survey data can provide once properly analyzed. When astronomers led by Sarah Greenstreet at NORLab analyzed how the asteroid's brightness changed over time, they discovered it completes a full rotation once every 1.9 minutes, the fastest rotation period ever documented for an asteroid of its size anywhere in the solar system. Scientists believe that extreme spin likely resulted from a violent ancient collision, the asteroid potentially being a surviving fragment of a much larger body that was shattered apart at some point in the deep past, a genuinely strange, previously unknown fact about our own cosmic backyard. Discovered purely because Rubin happened to look in the right direction during its very first week of operation. It's worth being precise here and genuinely honest about what all of this newly revealed material does and doesn't mean for actual safety. Discovering more asteroids doesn't mean more asteroids exist than before. It means we're finally building an accurate map of a population that has always been there, quietly, whether or not we had the tools to see it. NASA and NSF officials have specifically described Rubin as a genuine game-changer for planetary defense, precisely because its ability to catch smaller, fainter, previously invisible objects means our overall picture of what's actually out there in Earth's orbital neighborhood is about to become dramatically more complete than it has ever been in the history of astronomy. That's fundamentally a good thing. It's the difference between flying blind and finally having an accurate, comprehensive map of the traffic in your own airspace. The unsettling part isn't that danger has increased. It's the sudden, concrete realization of just how much has been out there the entire time, completely unnoticed, simply because nobody had ever pointed an instrument this capable in that particular direction before. That same unsettling scale extends beyond our own solar system entirely. Rubin's full 10-year survey is expected to observe roughly 20 billion galaxies over its lifetime, along with an estimated 17 billion individual stars never previously cataloged by any other instrument. Officials involved with this project have made comparisons that are almost difficult to fully process. Rubin Observatory, according to NSF leadership, will capture more information about our universe than every optical telescope throughout all of human history combined. That's not marketing language. It's a direct, literal claim about data volume, backed by the observatory's specific design, an enormous camera paired with a strategy built entirely around repeatedly scanning the full visible sky every few nights without interruption for a full decade. Astronomer Keith Bechtel has made a similarly striking comparison, noting that Rubin is expected to catalog more galaxies and more supernova-like curves in just its first year of full operation than every previous cosmic survey combined managed across their entire operational histories put together. Among Rubin's very first released images was one nicknamed the Cosmic Treasure Chest, showing a pair of galaxies actively merging, their stars visibly being torn loose from each galaxy in long, glowing tidal tails, direct, undeniable photographic evidence of one galaxy consuming another, caught mid-collision. A separate image of the Virgo cluster showed 3 galaxies simultaneously merging together in a single frame, alongside millions of other background galaxies, photographed incidentally in the same exposure. Dr. Yusra Al-Sayed, Deputy Associate Director of Rubin's data management team, explained that the camera's enormous field of view lets it capture detailed, close-up glimpses of interacting galaxies while simultaneously photographing millions of other galaxies scattered across the same wider frame, all in a single exposure. These aren't distant abstractions. They're real, physical events unfolding across the universe, captured by an instrument sensitive enough to catch them clearly in exactly the narrow window in their multi-hundred-million-year timeline when the visual evidence of collision hasn't yet faded or become obscured by dust the way older, more evolved mergers eventually do. There's also a quieter, more structural dimension to why this feels so disorienting, one worth sitting with directly. For the entire history of observational astronomy up until this point, our picture of the universe has necessarily been built from partial, incomplete glimpses, telescopes pointed carefully at specific, pre-selected targets, chosen precisely because astronomers already suspected they might be interesting. That approach works well for studying objects we already know to look for. It works far less well for finding the things we don't yet know exist at all. Rubin flips that entire logic. Rather than deciding in advance what's worth looking at, it simply photographs everything, repeatedly, methodically, across the entire visible southern sky, and lets whatever is actually out there reveal itself through that sheer, systematic coverage. That shift from selective observation to comprehensive, repeated surveillance of the whole sky is precisely why Rubin keeps turning up so much material that decades of more targeted astronomy simply never noticed. It was never that the material wasn't there. It was that nobody had ever built an instrument specifically designed to look everywhere, all the time, rather than only where we already expected to find something interesting. What ties all of this together, the newly discovered asteroids, the fast spinning fragment from an ancient collision, the merging galaxies, the 20 billion galaxies still waiting to be catalogued, is a single, genuinely disorienting realization. The universe we thought we understood, the solar system we assumed was mostly mapped, the night sky we've been photographing for over a century, turns out to have been mostly unexamined at exactly the level of detail and repetition required to actually see what's really there. Rubin isn't discovering a universe that suddenly became more crowded, more active, or more chaotic than it was last year. It's revealing a universe that was always this full, this active, and this dynamic, and that we simply lacked the instrument capable of proving it until now. That's the honest version of why this moment feels unsettling, and it's worth separating that feeling from any actual cause for alarm. There is no evidence of any looming threat, no newly discovered danger to Earth, nothing in Rubin's early findings that should keep anyone up at night worrying about their physical safety. What Rubin has actually revealed is something more philosophically disorienting than physically dangerous. The scale of our own previous ignorance about a universe we assumed we already had a reasonably complete picture of. Millions of asteroids we never knew existed, billions of stars and galaxies never before catalogued. An entire, continuously updating record of cosmic change that no previous generation of astronomers ever had access to, now running live every single night for the next 10 years, quietly rewriting exactly how complete or incomplete our picture of the universe actually was the entire time we thought we already understood it. If this story genuinely made you sit with how much has been hiding in plain sight, hit subscribe, because Rubin has barely begun its 10-year survey, and by every indication, it's going to keep finding just how much more there really is.